People came online instead. All right, so if you guys have your worksheet from yesterday, let's flip to that. Beautiful. All right, I'll take attendance for you people at home here in a second. All right. So yesterday we spoke about a few things. All right. Let's formally start this. So today we're going to do the last set of notes for the unit. And remember, we have our matter test on Thursday. Tomorrow we will review. You can also start the review tonight if you would like. The review is already in your packet. If you're like, man, I don't want to wait till the day before to review, you don't have to wait. We're going to do the concept map tomorrow. And the review sheet is already there and the key is online. So if you want to start reviewing today, please feel free. Okay. But other than that, I would like to go through just kind of a refresher on what we did yesterday. The separation technique that uses differences in boiling point. Does anybody remember what that one is? Yay, first period. All right. Distillation. Got to know these by Thursday. The separation technique that uses difference in density and solubility. It's the one that spins really fast over here in the centrifuge in the fume hood. I said the answer. Centrifuge. Giving up answers up here, I guess. Separation technique uses difference in solubility use it when you make coffee in the morning. Filtering. Thank you. And then the only other one, the one that is based on color, is chromatography. Okay. Awesome. Very good. Now this bottom part, if you did it, make sure you check it with me. I guess it's written more to, thank you. It's written more to have you kind of go through it with me. It kind of doesn't make sense. So let's go through it here. So glad you're here. Distillation can be used when you have a mixture of liquids and dissolved solids. Okay? Liquids and dissolved solids. You wouldn't want to distill something that had any solids in it. Okay, you might melt them, burn them, do whatever. Centrifuge can be used when you have a mixture of solids and liquids. You may not centrifuge anything that is dissolved. Remember, the food coloring over there was green. You could spin it until the cows came home and nothing would happen. Okay, dissolved does not work. Same thing with filtration. Dissolved solids will not filter out. Okay, so I think what we did is we tried to go through, and I kind of started this first one with you. And then on the back, if this one's kind of a little bit more challenging, on the back are a little bit easier. So if you want to start there, for instance, what separation techniques do you use to separate the parts of noodles in boiling water? What would you do? Do you distill it? Do you boil away all the water? What do you do when you're trying to get your mac and cheese noodles out of the water? Yes, very good. Thank you. You use a strainer, which is very simply a filter. Okay. You pour what goes through. The water goes through and you retain your solid noodles. Okay. What separation technique would you use to separate parts of lemonade? If you had lemon, sugar, and water, this might be a two-stepper. So you want to make sure that you know how to use the appropriate terms when you were doing these. And so I'm going to give a minute or two so you can try a few. Okay. Get some of this under your belt to make sure you're ready for the test. And if there's any questions like this on the test. So I'm going to give you a minute, take some attendance. You guys work on this. And then if you're already done, wherever in your notes you're keeping your matter stuff, probably right under yesterday's chromatography, we're going to hit the last little piece of notes. So we're going to start that here in about 5 minutes. But I will go over this worksheet with you. Let's see if you can't finish out the separations. So everybody feels good practicing that. Beautiful. Hey now, get out of there. Hey now. All right. Yes. Yes, run like the wind. Okay, I'm just dousing this thing in hand sanitizer so it's not wet because it's wet. It just, you know, and then rub it in your hands. That's good. But it's not, there's no germs on it. Let's see what I can see over here. Shall we? Okay, I'm going to go back to the harder one here real fast. All right, here we go. Here we go. So you have styrofoam beads, probably some iron shavings or something, and potassium bromide in a beaker. Okay. You want to kind of think when you're looking at how to separate a mixture of something else that you might need to do before you can start separating. If you have all these solids together, you can't really do much. So hopefully when you were doing the worksheet, you thought, hey, maybe if I add water into the beaker, that could get something to happen. If you put water in the beaker, there is only one soluble thing. The potassium bromide is going to dissolve. Potassium bro will dissolve. Wonderful. Then we have some less dense things that will go to the top and some more dense things, thank you, that will go into the bottom. So what you can do is you can centrifuge the less dense beads, your styrofoam beads, take them off the top. Then you can filter your iron shavings here. Beautiful iron shavings. And then you're left with some dissolved solids. And so the only thing you can do after that is you can distill. Your water will leave and your potassium, bromide will stay. Okay, so those are kind of some steps. That's more of a harder, challenging one. But so on the back are your more real world examples here. Lemon, sugar, and water. The first thing I would do is I'd filter out the lemons. Then you distill. That would take the water away from the sugar. Separation techniques used to take out salad dressing. You have oils, spices, and water. First, I would filter out the spices. Then I would centrifuge the oil to the top of the water and take that off. Boop. If I have plastic, salt, and water, like if you were cleaning up the ocean, a lot of these seem repetitive after a while. Filter out the plastic, distill away the water, and leave the salt behind or collect it, whatever you want. And then last, if you want to separate the parts of tie-dye powder, you just take chromatography. We don't really do a lot with chromatography. I think that's more in your biological and forensic sciences, but so it's in our standards, so you get to know it. Perfect. All right. So hopefully you feel good with those separation techniques. You'll find those on the test on Thursday. Then I want to go very quickly. We're going to do matter bell work number 2 at the end. So put that to the side here. And wherever you're keeping your notes, these should be pretty quick today. Pretty quick today. And our test again is on Thursday. So before I get started, I have a candle up here on my scale. Sitting here. Will you come up and read the number off of the scale for me? Just so nobody knows I'm not doing anything. I'm going to have you read it again at the end. So just tell me, how many grams is that?
87.59.
59?
Yes.
Sweet. Thank you. All right. So just at the corner of wherever your notes are, just jot that number down. Okay. So this candle is 87.59 grams. I'm going to take an igniter. Okay. And I'm going to light this candle on fire. And we're going to let this candle burn the entire time I'm talking about this lecture. And I want you in your head, right next to that number, I would like for you to write an A, a B, or a C. Do you think that the mass on the scale, is it going to read that the mass of the candle will increase? Is it going to read that the mass of the candle will decrease? Or is it going to read that the mass of the candle will stay the same? Okay, so write A, B, or C. And again, we'll do this at the very end to see how, and I'll probably ask you for this number, 87.59. Maybe I should write it on the side myself. 87.5. And then write A, B, or C. I'm not going to see this. I don't care if you get it right or not. I just want you to go with your gut, and I want to see where you're at on that one. Okay? Awesome. So today, we're going to talk about that. But today is kind of a catch-all. We're going to kind of solidify a few things that we've been kind of talking about, make sure we're ready to go into the next unit, which is thermochem, which is tough. We've been talking the difference between liquids, solutions, all that kind of good stuff. And I just want to take a moment and I just want to make sure everybody's on the same page. Okay. So again, I'd really only write the red portion. A liquid technically should only be used as a term when you're talking about a pure substance like distilled water, mercury, liquid iron. It is a state of matter. Okay. Liquid. It's a state of matter. Perfect. Okay. So this is sometimes used in the wrong manner, but that's okay. Water, ethanol, mercury, anything that is just nothing but it's a pure substance. Now, the other one I want to talk about, though, we should be talking about more of is when we're talking about a solution. Okay. A solution is a homogeneous mixture of something dissolved and dissolved ions. That will make sense to you more once we get into what ions are. And that means it's good and dispersed. It either looks all clear like in these bottles or it looks all blue like my copper sulfate over here. Then, just to toss it in here because you're going to see it a lot next unit, an aqueous solution, and you'll see the AQ here, is what 90% of our solutions are going to be. That means that they were made with water, an aqueous-based solution. Or a water-based solution is an aqueous solution. So if you make Kool-Aid, that's an aqueous-based solution. If you make salt water, any of the solutions in our class, some of our indicators will be alcohol-based, but 90% of the things that you use in this class are going to be water-based. So this is just something that I like to introduce so you can kind of sit on it for a minute because we are going to talk about aqueous things in the next unit. Okay. Awesome. So just a little clarification, soluble, insoluble, liquid solutions, aqueous solutions, all that kind of good stuff. Okay, shouldn't be anything too brain busting, but I just like to put it on there. All right, so now the other thing we're going to talk about, you might want to call this, I know it just says, but you might want to write parts of an equation. Parts of an equation. One of the beautiful things about chemistry is that most of the time before we do a reaction, it's not like mad scientists up here like, ha, 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 I wonder what's going to happen. We know what's going to happen. You can predict it. So this is not a skill that you're going to have to be able to do right now, but it's something you're going to have to be able to do in a second, or I would say about a month. Let's have you write this down. What I'm going to do is the same reaction we did yesterday. I'm going to take some magnesium sulfate, which is right there. So go ahead and write that down. Magnesium sulfate. You may or may not know when you are telling me that they're going to react together, you add a little plus sign, and then I'm going to react it with some sodium hydroxide. Okay. Awesome. So I would write those things down. This is the same thing that we did yesterday, but let's do it again. Magnesium sulfate. Put a little bit in here. Good fun. Clear solution. A little bit of this. Good fun. Oh, boom. White precipitate. Okay. So one of the things that you will need to be able to do by the end of the semester is predict what you're going to make. You will not predict these on the test tomorrow or Thursday. But one of the things we're going to make is magnesium hydroxide and sodium sulfate. So let's write those out. Magnesium hydroxide and sodium sulfate. So that is what a chemical reaction would look like. Now, you will have to know how to write the equations and balance it and do all that stuff later. But before we can get to all that, we got to talk about the parts of the reaction. The things that you begin with are called your reactants. I guarantee you this stuff will be on the test because I have to be able to say, hey, take a look at those reactants or balance your reactants, and you have to know where exactly to look. The things that you end with are called the products. The things that you end with are called the products. And this lovely little arrow here means to yield or to produce. Awesome. So what I would say is that magnesium sulfate reacts with sodium hydroxide to yield magnesium hydroxide and sodium sulfate. The interesting thing about this is that magnesium hydroxide, what you see under here, is telling me that it's a solid. That is my precipitate. Sometimes people write PPT for precipitate. And the sodium sulfate in my beaker is an aqueous solution. Okay, so in here I had magnesium sulfate, sodium hydroxide react together to make magnesium hydroxide and sodium sulfate. If it is a solid and this is a soluble solution, okay, I have a series of questions for you. Precipitate, and we already defined this. If you would like to write it again, you can. It's just a formation of a solid out of a solution. We already talked about that. Just to get ready to review with you, the fact that I made a solid and it changed from clear to white and all that kind of good stuff, what type of change is that? Do you think that's a chemical or a physical change we just had? You made a solid and it turned white. That is, oh, chemical. You got it. Thank you. At least you tried. Thank you. Okay. We reacted those two things together and we got that. The evidence being that, you might want to know the pieces of evidence here. Whoop. And you probably don't have to write this stuff. We're just reviewing. Solid was formed and a color change happened. That solid precipitate, is that soluble? It's a solid precipitate. It came out of a solution. So is it soluble? No. Okay. They're solids that come out of that solution. So if I have a solid in solution, what is one thing that I could do, talking about our separation techniques yesterday, to get this solid precipitate out of this solution? What is one? There are two. Go ahead, talk to me. You could use the centrifuge and you could filter. Okay. So again, these are all just kind of review questions, making sure we're being able to, go through some of the stuff in my head. That is what we had going on. The interesting thing about what you made here, this lovely magnesium hydroxide, this solid, it is actually the active ingredient in milk of magnesia. Okay. I usually push this in your face to make you read it, but I won't do that. We're trying to socially distance each other. But it says the active ingredient is magnesium hydroxide. Okay. So that white precipitate that we made here, is the active ingredient to help you neutralize stomach acid when you don't feel well. Now, I only like to bring this up because it's a really easy example of people that want to go into business and say that there's no chemistry in business. There absolutely is. Would you drink this if this was called magnesium hydroxide? Like, nobody wants to drink that. But then somebody came along and said, let's call that milk of magnesia, right? Because it's look kind of like milk with the little white cloudy bits, stuff like that. So kind of just getting people to trust it. Sometimes people are scared of chemical names, things like that. So milk of magnesia. Down to the other idea in business on this is, why is it an opaque blue bottle? Well, if it's a precipitate and a solid, this is the one I made yesterday, what is eventually that solid going to do? It's going to settle out to the bottom, right? And you have a whole bunch of liquid on top. What are the instructions that you always need to do when you have a medicine? The first thing before you pour it out, you need to do what? Shake it, right? To get that back up in there. And if you had a bottle that was clear and on the shelf was just sitting this chunky business, okay, would anybody want to buy that? No, right? So I sometimes like to take a time out and talk a little bit about how chemistry is everywhere. You might just pick this up to make yourself feel better, and you don't realize that somebody that understands chemistry has named it, written the directions of it, and designed the bottle. And they had to understand chemistry in order to do that, okay? So chemistry is in business, chemistry is in food, chemistry is in everything. So it's really good to make sure you're understanding some of these things, even if you think the chemistry isn't where you're going to go, you know, in your future career, okay? So that's that. Last question I have, just to throw it out there because I love to kind of ask. Can I filter Kool-Aid out of a Kool-Aid beverage? Can I filter? No. Why can't I filter Kool-Aid out of a Kool-Aid beverage? That's because Kool-Aid is dissolved. Okay? Whew. Apparently I wrote a lot of stuff. So just making sure you remember that dissolved things do not filter or centrifuge out. Okay? All right, let's get into it. We're going to do one more reaction. Then we're going to take a look at our candle. Then I'm going to let you practice. Then we'll be done. Here we go. I'm going to do this reaction one more time. But this time, I'm going to do it on a triple beam balance. I have two kind of guys here. So you don't have to rewrite this because you already wrote it on your thing. We'll put a little bit of sodium hydroxide here. And put a little bit of magnesium sulfate over here. Equal parts-ish. And then I'm going to, whoop, too far. Look, back before the days of the awesome balances that we have back there. These are the ones we had to use. Not fun. Oh, too much. Getting close. Oh, too far. Okay, I need you guys' eyes in the front here. I need this line here to line up directly with that line there. You see what I'm saying? All right, so we're going to go back this way. Is it lined up yet? Okay. How about now? Dead on, or do I need to? Pretty good. Oh, it's a little low. Okay, we're going to make it. Here. Oh, still a little low. Okay, we're going to get there. Don't worry. If our balances ever go out, everybody would love to measure with a triple beam balance. Now it's too high. Too high? We'll get there. We'll get there one day. Oh, as I move the whole thing. Hold on. Good enough? All right. So what we're going to do is we're going to say, let's see, that's 282 grams. Okay. So 282 grams is the mass before this reaction. Are you with me? Now, what I'm going to do is I'm going to take these two liquids, like we said, I'm going to react them together, and I'm going to make a solid. Do you think the mass is going to go up, down, or stay the same when I react those two things together? What do you think? What do you think? I'm making a solid, so the mass should, okay, stay the same, go up, go down. Think about it in your head. If the mass goes up, okay, then the line will go up. If the mass goes down, the line will go down. If the mass stays the same, it will stay the same. Are you with me? We're going to make a solid out of 2 liquids. Ready? 1, 2, 3, go. The mass went down, right? Went down. Am I forgetting something? What am I forgetting? Yeah. Oh, now let's see what's going to happen. Did the line go back to the middle? It did. So the mass did what? The mass stayed exactly the same. Why? It's called the law of conservation of mass. I don't care if you made a solid. I don't care if you made another liquid. I don't care what you made. Okay? Matter cannot be created or destroyed. Okay, so this is a big idea. I jot this bad boy down. This is a big guy, big guy. Law of conservation of mass. The mass before has to equal the mass after. Okay. Then I'm going to turn this on its head, but let's write it down first and let's see how it goes. Law of conservation of mass or law of conservation of matter. Some people call it mass. Some people call it matter. It's the exact same thing. Matter can't be created or destroyed. It can change forms. It just can't be created and it can't be destroyed. If it goes somewhere, it has to go somewhere. You can't just obliterate the matter. Okay? So it doesn't matter if that chemical reaction made a solid, if it made another aqueous solution. It doesn't matter what it made. It should always be 282 grams because every single little atom found another little atom, and they did the reaction and nothing left and nothing was added, correct? Okay, even if you made a solid. Now, as soon as I say that, because I like to be tricky, okay, did everybody get this written down? So you might want to add, it can't be created or destroyed. It can only change forms. Let's see if I can't make you scratch your head. We got our candle, correct? Okay, let's talk about it. 87.59. Do you guys decide if you like A, B, or C as your choice? You do? Do you mind? Thank you. Again, I didn't touch it. I have nothing to do with it. What are we looking at?
86.01.
What? Thank you very much. I appreciate it. 86.01. Heavens to Betsaloo. What happened to the mass? Went down. What happened to it? Oh, okay. It's not on there anymore, right? It's not on there. So I'm going to just one little thing. So the mass went down. Who knew the mass was going to go down? Yeah, okay. High five yourself. Good job. But you were like, just a second ago, you said the mass had to stay the same. That's silly. Okay, what's that doing? The main idea, so it said, does this violate the law of conservation of mass? Nothing was destroyed here. And you don't have to write this down. We're just talking. What you have, so it didn't escape as heat energy because energy doesn't have mass, but it escaped, and he was right. What it left was as smoke, soot. If you light a candle, you know it's fall, it's perfect. Your favorite like apple spice candle. Why do you light that? So then when you walk in a room, what happens? You can smell it. Where did that come from? It came from the candle. So something is leaving that candle and going into the air. Correct? So I'm losing mass. Is that being destroyed? No. If I could run around and grab every little CO2 particle and every little pumpkin spice particle or whatever and shove it back on the candle, the mass of the candle should still be 87.59. It's just we got about 2 grams somewhere up here in the air extra. Does that make sense? Okay, so it's not created. It's not destroyed. It can just change where it is going. Okay. Perfect. Very good. Now, usually I would give you guys some candles and let you guys play with this, but it's a pretty cool trick. You can do it at home. You can relight a candle from a very far distance because of all that vapor that you lose. Wonderful. Okay, so you blow it out, and then there's this smoke that comes off of it. And the smoke that comes off of it is very much flammable because it's just boiled away wax. And so that smoke that comes off, you can relight. I get a better slow-mo one up in here that shows you the actual wax. Boop. Let's pause you. All right, so here's another one. Okay, they're going to extinguish this candle. And then you'll see a whole bunch of boiled wax kind of come up. They're going to bring in a lit splint. And then they're going to relight that vapor. Wait, okay, it's super slow-mo now. Come on. There it is. And that kind of your flammable gas here is actually going to come back down, and it will relight your candle. So usually this is something that I would give you a bunch of candles and we would do, and it's kind of fun. However, I was about to get them out, and then I thought about how you're going to blow out a candle with a mask on, so that's out. But maybe one day if you have candles at home, you got to get them good and boily for a while, get a lot of wax on them, and then you blow them out, and you can relight that smoke that comes off of them. It's actually kind of cool. You can get it from far away, but if you kind of work at it. So what I want you guys to do, let's see. We have 5 minutes. I want you to open up your laptop. I would like for you to answer your 3 lecture questions. And then I would like for everybody to finish matter bell work number 2 for this afternoon. This is very easy. I just want to make sure that you kind of understand the scenarios. I'll turn the jams back on, or the lights back on. Thank you for your assistance today in reading the scale. That's nice. Worked good. So you're going to do your 3 lecture questions. Then I do want you to go through and finish matter bell work 2. If you would like to start to get to the review sheet, you can, or we will have all day tomorrow in class to finish it. Tomorrow we're going to talk about the concept map. I'm going to help you fill it in so you don't have to worry about that. I'm going to tell you exactly what the test will look like, and then we'll have our time to do the review sheet. Okay, so but the test will be coming at you. To be honest, I started to write the test last week. I tried to finish it a little more last night. It's going to be 30 multiple choice questions. It's going to be lame. I really would love to give you a nice hard thinker test, but it is what it is. So I will let you know. We're going to solidify it after school tonight so that you know exactly what it's looking. I know it says it's 1 billion points in Schoology right now. That's to remind me to change the grades, where I always forget to change a grade in a certain portion, and then it messes up everything. So, and then a reminder, this will go on Q1. So I might change the date, the due date on it, so it fits in Q1. But I think it's just best to put this lovely test on Q1. Does anybody have any questions? 3 lecture questions, get them done. Those of you at home, do your 3 lecture questions. I think I got everybody from home.